And good afternoon. So let's start our class. That's great. That is what I plan to do. Okay, so what we're going to do today is, kita akan bincang 3 topik. So the first topic is going to be on discussion on quiz 1. So the thing is that I have over here a screenshot of questions on quiz 1. Okay, however, so soalan yang you dapat might be different from what I have shown over here. Sebabnya soalan tu dia ada banyak set, but still I hanya tukar function, tukar what do you call that. But tapi konsep dia still adalah sama. So whatever that I've discussed in class today, so you are going to be able to apply that to your question as well. Okay, so the idea is going to be pretty much the same. And then I'm going to discuss topic 3.3. So in the video of topic 3.3, so I discussed about logarithm function, but I didn't actually show how to sketch for logarithm function. So that we're going to discuss for the second topic. And then we are also going to discuss a topic for this week, which is exponential growth and decay. So dia ada 2 formula. So one of the formulas I have already discussed in the video, but one of them I just noticed that in the workbook. So I think I have to explain to you about that as well. So let's start now. So I'm going to start with the quiz. So kalau you ada apa-apa soalan, just feel free to unmute your mic and interrupt me. So I don't mind that. So here I have a function. So if f of n is equal to n minus 4 and g of n is equal to 3n minus 3. So I asked you to find f of g of negative 1. So if you notice, my quiz question is actually straightforward. I rasa macam senang. Tapi mungkin I je lah yang rasa senang. Because when I see in terms of the performance, I don't think I've seen any full mark so far. I rasa macam tak ada full mark. But not many people actually got 10 and above. So mostly ada yang dapat 2, dapat 3 and so on. So that is like not a good grade. Okay, so you patut dapat 10 and above, then only it's good for your percentage of coursework mark. And ada juga seorang, so I actually took 2 days to set up the quiz. You jawab dalam masa setengah jam, but it take me 2 days untuk set up soalan dalam kalam. And someone actually spent 2 minit setengah jawab my quiz and dapat 2/15. If I were to set it for half an hour, so it means that you should utilize the time efficiently. Maknanya, like in half an hour, you patutnya you dapat jawab and then you boleh check you punya jawapan. Bukan jawab 2 minit setengah and then submit and then be done with it. I tak kisah kalau you jawab 2 minit, you dapat full mark. But the problem is that you jawab 2 minit, you dapat 12/15. So makes me wonder, yang you ni masuk, lepas tu tekan, then just submit ke macam mana? Okay, so please put some effort into your coursework marks. Okay, so now let's proceed with this one. So the operation is going to be f minus g. So I'm going to copy it down. So f minus g in terms of n. So first I'm going to do it in terms of the variable n. So that is going to equal 2n minus 4 minus, and g is going to be given by 3n minus 3. I'll letak kurungan dekat belakang for the whole function g. And then I'm going to simplify this. So I'm going to have 2n minus 3n minus 4 plus 3, because here, if you notice, I have minus and minus, so that is going to be plus of 3. And when I simplify, I'll end up with negative n minus 1. But the thing is that I don't want a function of f of g of n. So the variable, I don't want it to be n. I want it to substitute that with a constant value of negative 1. So now all I have to do is, I'm going to write this as f minus g of negative 1. So whenever you come across n in the equation, you're going to replace that by negative 1. So I'm referring to this n right here. So therefore, my equation is going to be a negative of negative 1 minus 1. So which is going to be 1 minus 1, that is going to equal 0. So the answer is supposed to be 0. So this is a very simple question. You will get 2 marks out of 15 for this. Okay, so that is the first one. As I mentioned before, soalan ni dia ada banyak set. What you might get might be different from this, tapi idea dia adalah sama. Okay, this is going to be the second question. So I gave you a graph of function f of x, and then I suruh you cari. So using the values from the graph, find 8/3 f of 8. So this graph over here, there are 2 variables. Satu adalah x, okay, satu lagi adalah for the f of x value. So if you were to refer to the value of x, you'll be referring to that axis. And if you want to know what is going to be the value of f of x, you will be referring to the vertical axis. Okay, sekarang I ask you to find what is going to be f of 8. So meaning that what happened is that, so the value of 8x is going to equal 8. What is going to be the value of f? So now I'm going to find in on the graph, so where is x equal 8? X equal 8 is going to be over here, and it is right on the axis. Can anyone tell me apa value f dekat situ? What is the value of f right there? F is equal?
0.
Exactly. So f is equal 0. So what happened is that, so I know that f is equal 0, I can substitute. So this is actually 8 over 3. So multiplied by 0, that is going to equal 0. So berapa jawapan dia? Jawapan dia is equal 0. That's it. Okay. Or if I were to pick another point, okay, katakanlah I tak nak F8. So I nak another point, F20. So what is going to be the value of F bila X adalah sama dengan 20? So it's going to be up here. So it's going to be pointing towards this value. So maknanya F20 kebetulan dia adalah sama dengan 20. Okay, so that is how you read the graph. So this is going to be the x value, this is going to be the f of x value. So it's going to be as easy as that, and you will get another 2 marks. Okay, question number 3. So if you remember, question number 3 is a piecewise function, and we have already discussed this in the previous lecture. I tunjukkan you piecewise function, and we pick a couple of values that we're going to evaluate from the piecewise function. So this is similar idea. I memang purposely bagi soalan yang sama because I wanted to test sama ada you sebenarnya bila kita discuss tu, are you aware of that or not? And I'm surprised that there are still people who got this wrong. So given the following function, so I have h of x function. So x, when x is greater than -2, so I'm going to be using this function x over 2 minus 4. And if the value is greater than -2, so it's going to be 3 minus 2x. So kalau I draw a number line, so this is going to be my value of -2. Okay, letak 0 supaya that you can have the idea. Okay, so that is going to be where 0 is. But when the function is equal or greater than -2, so which is going to be on this side, I akan pakai the first function. And when the value of x adalah lebih besar daripada -2, which is in this yellow region, I'm going to use the second function sekarang. So what is my value of x? So in here, I want to find what is going to be the h value when x is equal -1/2. So kalau I letak ni adalah region 1, region 2, so dekat mana x equal -1/2? Is it going to be in the first region or second region?
Second.
In the second region? That's right. So it's going to be in the second region because -1/2 dia adalah between, so -2 dengan kosong. Somewhere over here is going to equal -1/2. So that is going to be in the yellow region. Maknanya I akan pakai equation yang I highlight kuning kat sini. So h of -1/2 is equal, maknanya sekarang kita akan ganti dekat nilai x ni. So this is going to equal -1/2. So I'm going to get 3 minus 2 multiplied by -1/2. So that is going to equal 3. So this is going to cancel each other, plus 1. So the outcome is going to equal 4. So it's going to be as easy as that. So h -1/2 is going to equal a 4. And you will get 2 marks for the out of 15 for that calculation. That's it. Okay, and then for question number 4, so I gave you a table. So the idea for this sama juga macam graph tadi, cuma yang question 3 tadi, question 2 di dalam bentuk graph, but this is in term of a table. So I have 2 rows. So the first row adalah untuk nilai x. The second row is for the value of f of x. So kalau you nak tengok value nilai x, you tengok the first row. If you are going to refer for the f of x value, you're going to refer to the second row. So the question asks you, for what value of x sekarang kita nak cari? So apa dia nilai x? What is going to be the value of x when f of x is equal 3? So where is f of x equal 3? So this is f of x equal 3. And what is the value of x referring to that? So the value of x is going to equal 2. So therefore, for this case, this is going to equal 2. So that will be the answer. And for the second question, so I asked determine f1. So here, so what happened is that the value of x is going to equal 1. So what is going to be the value of f1? So where is x equal 1? So where x equal 1 is going to be right here. So this is my x equal, sorry, that's x equal -1. 1 is going to be over here. And what is going to be the value of f when x is equal 1? So it's going to be the value underneath, which coincidentally is also going to equal 1. So therefore, so my F1 is going to equal 1. That's it. So that is going to give you 2 marks. So 1 mark each for just reading the table. Okay, so question number 5. So this is actually a bit conceptual, and I rasa I tak ada rasanya orang yang betul soalan ni. So question number 5 ni. So actually it's just no calculation needed. It is very conceptual. I did mention in my video, so when we discuss about inverse function, so the fact that when we have a composite function between the f and the f inverse. So if I have f, so I compositekan dia with my f on inverse, so the outcome is going to be x. So if this is x, this is also going to be x. Or it could also be the other way around. So kalau I letak f inverse dekat depan, so I'm going to composite that with a function f. It's going to be the same idea. So this is still going to be x. So now all I did is that instead of x, so the value is going to equal 4. Can anyone tell me what is going to be the answer?
4.
Exactly. So the answer is going to equal 4. That's it. So tu sahaja jawapan dia. So kalau I ada f inverse f x or the other way around, macam yang I ada dalam quiz ni. So if this is 4, so automatically this is also going to equal 4. So this is concept. Okay. So kalau you ada f inverse, you nak verify betul ke tak you punya function f inverse, all you have to do is composite both of them and you akan dapat x. That is the relationship between the function f and the inverse. And the last question, so this question number 6. So question number 6 ni I ada buat banyak set of graph. So this is actually one of them. So I actually, for this one, I just asked about the function, whether it's a function, range, and also the domain. So how do we tell whether a graph is a function or not a function? So yang ni ada dalam topic 2.1. So it's called as the vertical line test. So this is what we do. So let me write over here. So it's called a vertical line test. So what you have to do is, you akan draw a vertical line. So line yang menegak. So if bila you draw a line dekat graph tu and it only touch one point, so that is going to be a function. The graph is a function. But if it touches at more than one point, dua atau lebih, so it is not a function. For example, this one over here, so it touches more than one point, automatically it is not a function. So you have to do it everywhere. Dekat mana-mana pun kalau you letak vertical line tu, whether it's going to be here, here or here, so they are going to touch at exactly only one point, so it's a function. And for what we have over here, so what happened is that, so if I were to draw a vertical line over here, so if you notice what happened is that it's going to touch exactly at only one point. So therefore, is this a function? So the answer is yes, it is a function. So that is going to be for the first question. Okay, and then second question will be on range. So if I were talking about range, should I refer to the x-axis or the y-axis for range?
Y.
Exactly. For range, I have to refer to the y-axis. For domain, I'll be referring to the x-axis. Sekarang nak tengok range dulu. So this is going to be my y-axis. So I have to observe the minimum and the maximum value on my y-axis. Okay, dekat mana minimum value dia? So the minimum value is going to be here. So that is going to be at -2. Alright? And the maximum value is going to be right here. So that is going to be a 2. Sekarang dekat -2, dia square bracket ke pakai round bracket? Is -2 included or not included? Square or round bracket?
Included.
Included, that's right. So kita ada satu tak included, satu included, tapi sebenarnya dia salah satu je. Dia kalau ada included, automatically both of them considered as being included. So for this case, yes. So it's going to be a square bracket. And dekat 2 ni, dia tak ada this open circle, automatically. So 2 is included, so it's going to be another square bracket. So meaning that for this case, the range is going to be -2 until 2, and both of the numbers are included. And the case for domain is also going to be the same. But for domain, we'll be referring to the x-axis. So kita tengok nilai minimum dengan nilai maximum. So minimum dia kat sini. So this is going to be the maximum. So I'm going to have -5 until 5. So here at -5, kita ada open circle. So it's going to be a round bracket. Dekat 5, kita ada closed circle. So it's going to be a square bracket. So that is going to be your domain. So that is all that I expected you to do, and you will get one question for each question, for 1 mark for each of the question. That's it. That is going to be for quiz 1. So any question about the quiz? Oh, I actually have another one. Okay, this is actually the hardest one. Okay, so this one is going to be 3 marks. So the rest of them are like 1 mark or 2 mark, but this one is going to be the hardest one. It's going to be 3 marks. So for this case, I have a quadratic function, and I asked you to find what is going to be the maximum point. But instead of like giving it in terms of numbers, I give it in terms of a constant k. If you remember what we discussed before, so this equation is given by f of x is equal negative x squared plus 2kx. So the general form of a quadratic equation is given by ax squared plus bx plus c. Okay, from this equation, first of all, what I'm going to do is I'm going to identify a, b, and c. So a is going to be the number that goes in front of the x squared, including this negative over here. But what value is a actually? Is it negative of 0 or negative of what? A is equal?
-1.
Exactly. A is equal negative of 1. Just because it's not there doesn't mean that it's nothing over there. So it's actually negative of 1. And B is going to be everything that goes in front of x. And for this case, it including the constant 2 and also the constant k. So therefore, my B value is going to equal to k. And what about C for this case? What is my C value?
0.
Exactly. So here, actually, none means that it's going to be 0. All right, so I mentioned this to you before. So if we have a quadratic function and we wanted to find the turning point, so a turning point could either be maximum or minimum value. So there are 2 ways of doing that. One is going to be completing the square, which is not going to be easy for this case. And the other one is going to be using the formula, so which I encourage you to use. And using the formula, how do we find the x coordinate? So the formula is negative b over 2a. So based on the values that we have found here, I'm going to put it in the equation. So I will get negative b is going to equal to k over 2. My a value is going to equal -1. This and this, they're going to cancel. I'll end up with negative k over -1, so which is going to be a positive of k. So that is going to be our x coordinate. So C and D is already ruled out. So the answer could only be A and B. And now I'm going to find what is going to be the y coordinate. All I have to do is find f of negative b over 2a. But we already calculated negative b over 2a. That is going to equal k. So I'm going to find what is going to be f of k. But before I start my calculation with f of k, let me explain to you a very simple concept. So let's say if I have a function, let's say it's g. So g of x is equal to x plus 3. So what is going to be the function g of y? Can anyone tell me what is g of y? What happens if I change the variable? It's going to be 3? No, it's not going to be 3.
3 over 2.
Okay, so here the idea is I have g of x. My g of x is given by 2x plus 3. I change it to g of y now. So what is going to be the new function? It's going to be in terms of y.
2y plus 3.
2y
2y plus
3.
3.
Exactly, it's going to be 2y plus 3. Remember, all you have to do is change the variable. Every single time you come across x, you change that to y. So this is x, you change that to y. So that is going to be the idea. How do you change the function? So this is what I expected you to do as well. So previously, this is going to be in terms of f of x. Our variable is x. Now we're going to change this and make it in terms of k. So everywhere there is x in the equation, so I'm referring to this x and this x, I'm going to change them to be in terms of k. So therefore now my equation is going to be negative, so k to the power of 2, so plus 2k. Anything else that is not x, just copy it down. So this is not x, copy it down, but I come across x, now replace that is going to be k and plus 0. And when I simplify this, I will get negative k squared plus 2k squared. So 2 minus 1, that is going to be a k squared. So what is going to be your fk? So fk is going to equal k squared. So that is my y coordinate. So the answer is going to be k and also k squared. So which is going to be A. So that is all that I expected you to do. Okay. And I noticed something about you guys is that when it is not in terms of numbers, when I give k, when I give A, when I give B, so it freaks you out. Remember, if something is a constant, so treat them exactly the same way that you treat numbers. Okay, don't get intimidated by them. Jangan segerun tengok k ke A ke B. So it's very common. So as you get to the higher level maths, so there's not going to be much numbers anymore. That's how it goes. Okay, so that are all 7 questions altogether, and that's it. So do you have any question about the quiz before we proceed to what do you call that, to the next agenda?
No, madam.
Okay, so if you don't have any questions, I'm going to proceed to the second point I'm going to deliver today. So which is sketching the logarithm function. Okay, first of all, so let me tell you about logarithm function. So if you have your calculator with you can use your calculator for this. So the thing about the logarithm function, so log of 0 is not possible. You cannot take a log and it cannot take a 0 and log it. It doesn't exist. So what happens is that when you press log of 0 on your calculator, so it will give you a math error. Because in mathematics, anything that is log of 0 doesn't exist. Okay? Or what if you have log of negative number? Let's say you pick log of -1. Log of negative number also does not exist. So basically, so whatever that goes in the bracket that you want to log, so it cannot be 0, it cannot be a negative number. And prove here, so cannot be 0, so cannot be negative. Okay, so those are going to be the 2 rules for the number or the function that you want to log. So basically, if I have log of the function f of x, so let's put a general form of here. So let's say the bracket is going to be a function of x. So the condition is that the f of x, it must be a number that is greater than 0. Because it cannot be 0, it cannot be negative. So it must be a number that is greater than 0. So this is going to be the idea that you're going to apply when you want to find the domain for logarithm function. So here I have 4 functions that I'm going to sketch. But I think I'm going to sketch just 3. I'm going to leave out C because C and D, once you have a look at D, you will get the idea for C as well. So I'm going to leave C to you, but I will sketch the rest starting from A. So for A, I have a very simple function, so which is f of x is equal log of x. So before we sketch, first of all, so we need to know what is going to be the domain. As I mentioned before to you, so whatever that goes inside the bracket, it must be a function that is greater than 0. And for this case, so what is going to be our domain? So our domain is going to be anything that x is greater than 0. So is 0 included? No, because you cannot have log of 0. So that is why the domain, so it's going to be a what I call it, a round bracket, not including 0, and it could be until infinity. Okay, so when I say that not including 0, so what number goes after 0? The number is going to be 0.0001, 0.0002, and so on. So those are the numbers that goes after 0. It doesn't start with 1. So right after the number that goes after 0, so it start already. And what is going to be the range? And if you use your calculator for this, if you find what is going to be log of 0.001, what is going to be log of 0.5, so what happens is that you will get negative values. So you can use your calculator for this. You can either use ln, you can also use log. Both of them are going to give you pretty much the similar thing. Both of them are going to be, the number might be different, but they are both going to be negative. Okay, and if you were to find, for example, log of 2 or log of 3, so what happens is that they are going to give you a positive value. So the idea that I want to deliver here is that, so the fact that, so for the range, when you log a number, so it could be negative and it could be a positive number. There's no restriction. So which is why the range could be from any value from negative infinity until infinity. So when you sketch for logarithm function, there are going to be 2 characteristics that you should include. One is going to be the asymptote. What is asymptote? And it should be an x-asymptote. So asymptotes mean, so border, it's a border of values that's not possible for x. Okay, so that is known as the x-asymptote. And then, so the second feature that you should have, the second characteristic that should be on your graph, so will be the x-intercept. So this is definitely not going to intercept the y, so we don't need the y-intercept. So we're only going to need the x-intercept. And of course, how do you find the x-intercept? So x-intercept is going to be the value of x when y is equal 0. So the idea is as easy as that. So now let's start sketching. So let's suppose this is going to be my axis. So what happened is that, like, I don't need it to be down here though. Let's put it a little bit up there. Okay, let's make it here. Okay, first of all, I know that where is going to be the border? So x must be a value that is greater than 0. So that is why. So my asymptote is going to be at x equal 0 because it cannot be 0, it cannot be negative. So the border will be at 0. So somewhere over here, so this is x equals 0, which is right on the y-axis. So this is going to be the asymptote. So your graph, it shouldn't cross the asymptote. So that is what the asymptote for. Okay, and then for the intercept, so if I were to find the intercept for this, I'm going to have y is equal log of x. So now my log of x is equal 0. So I just take from the original equation. So x, we know that I mentioned to you this repeatedly over and over again. How do we cancel log? So we can cancel that because log is, ln is log base e. So we can cancel that by exponentiating both sides of the equation. So exponential log of x is going to equal exponential of 0. So this to cancel, x is going to equal 1. So when when y is equal 0, so x is going to equal 1. So this is where it's going to intercept. So when I sketch this graph, so how the graph looks like, so it's going to look like this. It's going to come very close to the asymptote, but it will never cross the asymptote. Okay, so it's just going to be a curve like that. So that is how the graph of logarithm looks like. So if you remember, it's very similar to the shape of graph of square root. So if you have sketched the graph of square root before, right? So that is going to be for the graph of f of x equal log of x. Now I'm going to sketch the second one, f of x equal 2 log of 2x. Okay, so it's going to be pretty much the same idea. Can anyone tell me for this case, what is going to be our domain? Based on what we discussed before, what is our domain?
2.
2.
No, it's not going to be 2. This is the concept that we're going to apply. So what is our f of x for this case? Our f of x is going to equal to x.
0.
That's right. So Shafika said it's going to be from 0 to infinity. So that is correct. So all you have to do is you take whatever in the bracket. So 2x must be greater than 0. So x must be greater than 0. Okay, and now we can also identify that there will be a asymptote at x equal 0. So the domain is going to be from 0 and it's going to go until infinity. And the range, so as what we have seen before, so the range remain, it is always going to be from negative infinity until infinity. Okay, I already have the asymptote. Now I need the other one characteristic, so which is the, what I call that, the x-intercept. So I'm going to have my equation is y equals 0. So 0 is equal to log of 2x. When I move this to the side, I will get log of 2x is equal 0. Again, how do we get rid of the log? We are going to exponentiate both sides of the equation. So this is, sorry? And this is going to cancel. So I'm going to have 2x is going to equal 1. So x is going to equal 1 over 2. So that will be the intercept value. Okay, so when I sketch this, so this is how it looks like. And what do you call that? The asymptote will be right in the middle as what we have seen before. So it's still going to be the value of x equals 0. And the intercept is going to be somewhere over here. So it's going to be a value of 1 over 2. And the shape is going to be exactly as what we have seen before. Just going to be a curve that looks like that. So that is going to be the graph of 2 log of 2x. So I'm going to sketch the last one before I proceed to the other topic that I want to discuss. So I'm going to sketch this one. So log of x minus 1 plus 2. Okay. For this one, anyone can tell me what is going to be the domain? What is going to be the domain for this one?
Negative.
Negative.
0, negative.
No, there will be no 0.
1, infinity, 2.
Betul.
One.
Okay, so remember, simply take everything in the bracket. Now it's going to be x minus 1. The function in the bracket must be greater than 0. So x must be greater than 1. And we're going to have a asymptote at x equal 1. So the domain is going to be from 1 and it's going to go until infinity. That is going to be the domain, and the range is going to be the same as before. So it's still going to be from negative infinity until infinity. The restriction is only going to be on the domain, but the range is always from infinity until infinity. And now I also need the intercept as well.
Madam, I want to ask why we don't.
Sure. Siapa dia, Amir? Kenapa tak apa? Okay, I'll proceed first. You can ask the
Why
question
we
in a bit.
don't take plus 2? We just take x minus 1.
Okay. Okay, sebabnya bila kita cerita pasal domain, we are only concerned about the x. Okay. So the y over here, it doesn't matter. So the plus 2 dekat sini, dia akan mengubah nilai y, but it wouldn't do anything about the value of x. So bila kita nak tengok domain, kita hanya tengok function yang ada x saja. So which referring to the function at the front over here. So sebab kita tahu limitation dia adalah log tu dia tak boleh nilai yang negatif ataupun kosong. So 2 tu kita just leave it be for now. So 2 plus 2 dekat belakang tu dia hanya akan mempengaruhi nilai y, tapi dia tak mempengaruhi nilai x. So that is the reason. Okay, so now if I were to proceed with the intercept, so it's going to be the same idea as previously. So log of x minus 1 plus 2 equals 0. So this is what I'm telling you, that it's going to only affect the value of, this 2 is only going to affect the value of y. So I'm going to have log of x minus 1 is going to equal negative 2. So I'm going to exponentiate both sides. So I can add x minus 1 is equal exponential of negative 2. So x is going to equal exponential of negative 2 plus 1. And if I'm not mistaken, so this is going to be 1.35 something. So you can calculate that for me. But the idea is going to be 1 point something plus. So if I were to sketch this, so it's going to be the same as before. But now my asymptote is going to be at x equal 1. So where is x equal 1? So let's say it's going to be somewhere over here. So this is where x is equal 1. So that is going to be my asymptote. And then my intercept is going to be at 1.135, which is super close to the asymptote. So let's say it's going to be somewhere over there. So therefore, this is how the graph looks like. Okay, so that is going to be our graph. So the idea is pretty much going to be the same. You only have to find the asymptote and also the intercept. And that is going to change according to your function. So remember, when you deal with domain, you only have a look at the function that is related to x. So when it comes to range, then you're going to have a look at the whole thing because it's going to be related to y. Okay, so I left you to do C, and I'm pretty sure that you have this kind of exercise in your book as well, in your workbook. So now I hope that you get the idea. So how do we sketch for logarithm function? Okay, so next I'm going to talk about exponential growth and decay. So this is in topic 3.6. So topic 3.6 adalah topic this week. So I've sent you the video, the link to the videos. And in the video, so actually, let me explain to you about the formula first. So there is going to be two equations that we're going to use for exponential growth and decay. So this is the first equation, and this is the second equation. So what I explained in the video will be the second equation. So this is what I explained in the video. Okay, and I just noticed that you actually have another function, another equation, which is at the top right here in the workbook. So I think that I need to explain this to you as well so that you will get the idea. Okay, so what is the difference between these two equations? So the first equation, you're going to use this for both growth and also decay. So dua-dua equation ni you akan pakai untuk growth and decay. Apa beza antara growth and decay? So you akan pakai growth bila y tu dia increase as time goes by. So amount tu dia bertambah, so tu adalah a growth process. But the thing is that when as time goes by, the amount decrease, tu kita panggil dia sebagai decay. Decay is reput dalam bahasa Melayu. Okay, so as of course when something reput, so the amount is going to decrease. Okay, when are you going to use equation number 1 and when are you going to use equation number 2? So we use equation number 1 when it happens on a regular interval. Okay, apa maksud it happens on a regular interval? Maksudnya, dia bukan berlaku all the time, but it happens, for example, dia boleh jadi berlaku weekly ataupun dia berlaku secara yearly or annually. So those are the term. Okay, maknanya, okay, kalau dia it happen today, bila lagi benda tu akan berlaku, tahun depan baru dia berlaku, tu adalah kita panggil dia sebagai regular interval. Dia ada kala dia. So bila benda tu akan berlaku. So it doesn't happen all the time. So that is called as a regular interval. And when we have cases like that, we're going to use this formula. So yt equal ab to the power of t. And then we also have the second formula. So bila kita nak pakai the second formula, so the second formula, we're going to use this when the growth and decay happens continuously. Right, so when it happens all the time, so bila setiap saat pun benda tu berlaku, so that is called as a continuous process. Okay, so contoh dia adalah growth of bacteria. So growth of bacteria ni, so it happens very rapidly. Dia berlaku dengan sangat cepat. Like it might be happen dalam split half second, daripada 1 dia dah jadi 10. Tambah lagi like another half second, it becomes 100 and so on. So it's a continuous process. Ataupun kalau kita ada radioactive substance, benda tu reput, it happens all the time. Dia tak ada berhenti. Okay, lepas sejam pula benda berlaku, tak. It happens continuously. Bila ada cases yang macam tu, so kita akan pakai formula yang kedua. Okay, now let me explain to you about the term. So I don't have space here. So let me put it down here. So formula yang kedua I dah explain dalam video. So go and watch the video. Tapi I nak explain pasal formula yang pertama. So the first formula is in term of yt is equal ab to the power of t. So dalam you punya buku dia pakai x, it doesn't matter. So boleh pakai variable x, boleh pakai variable t. But for me, when benda tu dia constant pasal time, I prefer to use t. So that kita tahu, okay, it's yt. So the independent what changes is going to be the time. Okay, so here we have a. So apa dia a? So a is called as the initial value. Okay, apa the initial value? Its initial value means at time t equals 0, what is going to be the value of y? Masa kita start experiment, masa kita start proses tu, okay, berapa nilai y? So that is called as the initial value. Value masa mula-mula, masa start, when we begins. Okay, so that is going to be the value of a. So the value of b, so b ni pula, okay, so dia adalah index, it is raised as b to the power of t. Okay, b is known as, so I don't think there's a specific name for b. Tak ada b, dia tak ada specific name. But we're going to have b to the power of t. So b ni, kalau nilai dia, if b is greater than 1, so proses ni dia adalah growth. Okay, so macam mana kita nak tahu equation tu untuk growth ataupun untuk decay? So based on the value of b. So b ni dia dalam bentuk index. It always in index form. Dia adalah b raised to the power of t. So that is going to be our b. Something yang raised to the power tu adalah kita punya b. Yang tak ada power tu adalah kita punya a. Dia bukan tak ada power tapi dia a kuasa 1. And what happen is that if the value of b adalah lebih kecil daripada 1, and that is going to be a decay process. So kalau dia bagi equation, for example, so katalah I bagi equation, so yt adalah sama dengan 3 darab 5 kuasa x. So macam mana you nak tahu ni adalah decay or growth? Based on this value, ni adalah b sebab dia raised to some power. So that is going to be our b. So this B value adalah lebih besar daripada 1, automatically it is going to be growth. And apa dia nilai A? Yang kat depan ni, yang tak ada kuasa, yang kuasa 1 ni, so this is going to be your value of A. So that is how you tell what is going to be A and what is going to be B. Okay, and the thing about B is that, so B ni kalau untuk growth, kita tulis dia sebagai 1 plus R. And apa dia R? So R is known as the growth rate. Okay, salah satu hint of like how do we know that kita akan pakai formula ni instead of the second formula, kalau dalam soalan dia bagi growth rate. Ataupun kalau untuk decay, so B ni dia adalah 1 tolak R. So what is R? R is going to be the it's going to be the decay rate. Kalau dalam soalan tu dia kata growth rate is given by 4% or decay rate is given by 4%, automatically kita tahu yang kita akan pakai this formula. Kalau tak, hint dia is going to be annually, weekly, yearly. So that is going to be a hint that this is going to be the formula that we have to use. Okay, what I've written over here is a summary of what I have explained to you just now. So exponential growth, this is going to be the formula. A multiplied by 1 plus R to the power of T. And so bila B lebih besar daripada 1, of course bila ada 1 tambah R, R is going to be a number that is greater than 0. So B tu akan jadi lebih besar daripada 1. So it's going to be the growth rate. And kalau 1 tolak R, of course bila kita ambil nilai 1 tolak R, dia nombor tu akan jadi lebih kecil daripada 1. Bila B lebih kecil daripada 1, that is going to be decay rate. So let's have a look at the workbook that you have. Okay, so this is the workbook. Let me clean this first. So there are 3 examples are given over here. So dia kata kat sini, so determine whether the following functions, I'm referring to this bullet, model exponential growth or exponential decay. So daripada function ni, kita nak tahu dia adalah growth ataupun decay. So how do we tell it's growth or decay? It's going to be based on the value of B. So like I mentioned just now, B lebih besar daripada 1, so it's going to be growth. And B lebih kecil daripada 1, it's going to be decay. Okay, for A, apa nilai B untuk A? Someone tell me what is the B value?
2x.
2.
2. So the value of B adalah 2. Ingat tak kita belajar index sebelum ni? Kalau kita ada 3 kuasa X, 3 dekat bawah ni kita panggil dia sebagai base. The base value tu adalah B. Okay, for this case, so your A value adalah 4. So your B value adalah sama dengan 2. So that is why, because B is greater than 1, so dia adalah exponential growth. Okay, for the case of B, kita ada Y sama dengan 0.25 kuasa X. Apa dia nilai A? For B.
A tak ada.
Kosong.
Tapi kalau
Kosong.
kalau kosong darab function dia jadi kosong.
1.
Exactly. Sebenarnya dia bukan kosong tau. Dia ada nombor kat depan ni. Dia adalah 1. 1 darab 0.25. Okay, so for this case, A adalah 1. So B adalah 0.25. So because B is less than 1, sebab tu dia adalah decay.
C.
Okay, untuk C pula, apa nilai A untuk C? Ha?
1.
Nope. No, it's not 1.
5.
Exactly. The value of A untuk C adalah 5. Because, so ni kalau kita belajar index sebelum ni, 5 kuasa X tambah 1, kita boleh pecahkan dia. So we can write this as 5 multiplied by 5 to the power of X. Sebab tu apa dia nilai A? Nilai A adalah 5. So nilai B adalah sama dengan 5. Ni index punya formula. So kalau kita ada base, let's say I ada X, A tambah B, dia sama dengan XA darab dengan XB. So this is the index property that we have seen before. Okay, so that's why for this case, apa dia nilai A adalah sama dengan 5. So don't get tricked by this. Okay, let's have a look at what we have over here. Ni I discuss dengan section sebelum ni. So let erase this. Okay, for the first example, so this is our equation. So it's written as this. So 1200 multiplied by 1 plus 0.3t. So yang raised to the power of t ni, dia adalah sama dengan b. So tanya kat sini, so does this function represent growth or decay? Of course kat sini b adalah sama dengan 1.03, lebih besar daripada 1, exactly. So it's going to be growth, obviously. Lepas tu dia tanya lagi, apa dia initial value? So initial value adalah nilai Y bila T sama dengan kosong. Tapi sebenarnya tak kira pun tak apa. Sebab ni kalau you tengok dia adalah nombor yang kat depan ni. Tu adalah kita punya initial value. Dia adalah A. So A for this case adalah 1200. And then it asks you what is the rate of growth and decay. Okay, so the thing about B adalah, so B is equal 1 plus R. So sekarang nilai B adalah sama dengan 1.03 adalah sama dengan 1 plus R. So berapa nilai R? So R adalah sama dengan 1.03 tolak 1. So which is going to equal, no, this is, why does my handwriting looks like this? So let me fix this. So dia adalah 1.03 tolak 1. So which is going to equal 0.3. No, this is 0.3, not 0.03. Let me fix this first. So 1.3, this is 1.3, and this is going to be 0.3. So for this case, dia punya rate growth adalah 0.3. And 0.3, you boleh tukar dia dalam bentuk percentage. So dia adalah 3%. So that is, 30%. So that is going to be 30%. So usually, bila kita cerita pasal rate growth ataupun rate decay, memang kita express in term of percentage. Tapi bila you jumpa percentage dalam you punya calculation, of course you kena tukar dia dalam bentuk perpuluhan. Baru you boleh buat operation nak tambah, nak tolak and so on. Okay, I don't want to discuss this one, tapi I nak discuss kat bawah ni pasal decay. Because you already seen growth. Okay, so the question for, this is the equation given. So the question asks you, does this function represent exponential growth or exponential decay? Idea dia sama macam tadi. So this is going to be our B. It is less than 1. Automatically that is going to be decay. Betul. Dia adalah decay. Dan soalan ni tanya lagi. So what is the initial value? Apa initial value kita sekarang?
5575.
Betul. So A adalah sama dengan 5575. So nombor dekat depan index ni yang kita darab dengan index tu. So that is going to be our A value. So what is the rate of growth or rate of decay? So untuk case ni dia adalah rate of decay. Sama juga macam tadi. So bila dia decay sebenarnya ni adalah Y sama dengan A B kuasa T. Ataupun A darab dengan 1 tolak R kuasa T. So kalau dia adalah decay, so B adalah sama dengan 1 tolak R. Kalau dia adalah growth, B adalah sama dengan 1 tambah R. Ni macam yang saya tulis kat sini. Here. Ni beza dia. B 1 tambah R bila dia growth, and dia adalah 1 tolak R bila dia adalah decay. So for this case, kita boleh tulis dia. So C, what is, so our B value adalah sama dengan 0.65. So this is equal 1 minus R. So apa dia nilai R? R adalah 1 tolak 0.65. So that is going to equal 0.35. Ataupun kita boleh tukar dia dalam bentuk percentage. Dia adalah 35%. So that is going to be our rate of decay. So kalau question tanya you pasal rate of decay. Okay, let's have a look at another one example. So I buat growth pula satu. So let's try this one. Okay, soalan ni, so macam mana kita tahu yang kita kena pakai formula yang pertama? Ada dua hint kat sini. So the first adalah dia bagi this percentage. So percentage ni
pakai formula yang pertama.
Ni formula dia tadi kan cakap ada dua formula. So ada dua formula ni, formula 1, formula 2. Ni kita tengah cerita pasal formula yang pertama. Formula kedua nanti tengok video. Okay, macam mana kita nak tahu yang kita kena pakai YT sama dengan AB kuasa T? Okay, hint dia adalah satu dia bagi percentage. Bila dia bagi percentage, so ni adalah kita punya R. Tapi kita tak tahu sama ada dia adalah growth ataupun decay. Ni you kena baca balik soalan. Okay, the second hint adalah dia kata benda ni annually. Dia berlaku saya tak tahu. Dia tak continuous tapi dia berlaku every year. Habis setahun baru benda tu berlaku. Habis setahun baru benda tu berlaku lagi and so on. Okay, so that is time interval. So that is why kita kena pakai this formula. Tak boleh pakai yang ada exponential tadi. So exponential tadi I'm referring to this formula. This is the second formula you akan tengok dalam this chapter, this subtopic. Okay, and then macam mana kita nak tahu ni cerita pasal growth ataupun decay? Dia kata the population increases. Bila something increase, dia makin banyak, automatically this is talking about growth. Okay, let's have a look at this. So example tu you boleh tengok sendiri, but I'm going to do this exercise with you. Dia kata the first year of a charity walk event, so kita ada event, so tahun pertama kita ada attendance dia adalah seramai 500. So the attendance Y increases, so Y itu adalah referring to kehadiran, berapa ramai orang yang hadir. So increases by 5% each year. So bila dia kata increases, so ni adalah referring kepada growth. And growth by how much? Dia punya rate R adalah sama dengan 5%. So question A dia kata, write an exponential growth function to represent this situation. So maknanya all you have to do is, you ambil this formula, so you kena ganti nilai A dengan nilai R. So let me put down the formula. So you can have A untuk growth, dia adalah, why did I put equal there? So Y of T adalah sama dengan A darab dengan 1 plus R kuasa T. So this is going to be our equation. Tetapi dalam equation ni, Y dengan T sahaja adalah variable. So selain daripada Y dengan T, so nilai lain you kena ganti. Mana nak cari nilai tu? So nilai tu ada dalam soalan. So what is my A value? Kalau you baca soalan ni,
500.
A value dia berapa? Betul.
500.
So bila first time kita buat event tu, tahun yang pertama, so kita assume dia adalah T equal 0 at the beginning. Bila kita start calculate, so dia adalah sama dengan 500. So therefore, this is going to equal 500 multiplied by 1 plus R. Kita dah ada dah, rate dia adalah 5%. Macam saya cakap tadi, kalau dia bagi dalam bentuk percentage, tukar dalam bentuk decimal, then only you can calculate. So dia adalah 0.05 lah, 5%. And raised to the power of T. So that is going to be our function. Okay, and then we're going to have B. So dia kata how many people will attend in the 10th year. So maknanya dia suruh you cari apa dia nilai Y. So bila T adalah sama dengan 10. So tahun first tadi kosong. Tahun yang ke-10 dia adalah 10 lah. So what you have to do is, you hanya pakai balik equation tadi. So kita akan ganti. So T ni adalah sama dengan 10. So I'm going to copy down the equation. I'm going to have Y of 10 is equal 500. 1 plus 0.05 raised to the power of 10. So what is the value? Berapa nilai dia?
814.447.
814.447.
814.447.
Is that right?
447. Approximately 814.
840. What's the value, Siva?
814.
814 is correct. This is correct.
0.447.
0.447.
447, yes.
Okay. Okay, but the thing is that it says over here round your answer to the nearest persons. But sekarang kita bercakap pasal attendance, kehadiran. So dia tak boleh kehadiran tu ada berapa orang datang, 81.5. Tak boleh ada perpuluhan. So when we talk about people, yeah, so it's going to be approximately 1814 people. Okay, but usually when it comes to people, instead of rounding it down, I prefer we to round it up. So let's make it 115 people instead. Okay, because that value is actually very close to being 5. So it's going to be 815 people. Okay, so the idea is first you have to formulate the equation. So you kena cari apa dia nilai A and nilai R dalam soalan. And then you akan pakai balik equation you untuk cari whatever that the question asked you to do. So that will be the idea. Okay. And this will be pretty much the same, just in terms of decay. But the idea is still going to be exactly the same. Yang ni adalah menggunakan equation yang nombor 2. Yang ni tolong dengar video tu. So I've explained that to you in detail. And you boleh buat exercise that you have in the workbook and in the slide as well. So I think for me, that is all. So do you have any question about anything? It could be about the topic that we discussed today, or it could be about anything that you have already studied.
Madam, can we, miss, can we review the formula 2?
Okay, sure.
Any question related to the formula 2? Maybe.
Or you want to see the formula 2, the example you mean?
Yeah.
So the yt is equal y naught. Okay, this is actually formula number 2. So it's actually an equation of yt is equal y naught exponential of kt. But the idea is going to be pretty much the same as for the case of the first formula. So y naught over here is still the initial value. Okay, so meaning that when t is equal 0, so what is going to be the value of y? So that is y naught. So the 0 over there is called as naught. And this k, so you are going to find the value of k, so based on information that you have in the question. Okay, let's pick. Okay, we can actually pick this question. So this is going to be a very simple one. So it says over here the exponential function. So we have an equation of pt is equal p naught exponential of kt. If you notice, the only difference is that I'm using y just now, and this is in term of p. Only the variable change, that's it. But the equation is still exactly the same. So it models the population of Mexico in millions, where k is the growth constant. So now if you notice, we're not using the term rate. It says it is the growth constant, but it is not rate. Rate referred to the previous formula. So use the fact that the population was 6.1 million in year 2000 and 7.5 million in year 2012. So it says over here, so determine the growth constant K. So for this formula, so the first thing that you have to do is you have to extract information. And there will be two information given. So can anyone tell me what is the first information given? The first information given will be about t equals 0. So what is the value of p when t is equal 0?
6.1.
Exactly. So we are going to assume that year 2000, so that is going to be the beginning of the story. So that is going to be t equal 0. Okay. And it says over here in year 2012. So how many years has passed since then? 12 years, that's right. After 12 years, when t is equal 12, so the population is now 7.5. So that is not just 7.5, but it's 7.5 million. But let's make it short in terms of calculation. So based on this information, so you're going to find what is going to be the growth constant, k. Okay, so what I'm going to do is, I'm going to have to use both equation over here. So first of all, I want you to bear in mind, so what are the variables for this case? There are only two variables, which is going to be p and also t. Anything that is not p and t, those are going to be numbers, constant. And that's referring to the p naught and also the k, meaning that you have two values to find, so which is going to be the p naught and k. Saya pun ganti. So A, so we're going to find the growth constant. So first I'm going to substitute that when t is equal 0, so p is going to equal 6.1. So there goes my p. So sebenarnya dalam equation ni dia tulis p of t kan. So this is pronounced as p of t. Dia bukan p darab t tau. Dia p of t. Dia menandakan, so p ni akan berubah bila t ni berubah. Okay, and dia tak ada masalah pun. Kita boleh tulis dia sebagai p sama dengan p naught exponential of kt. Dua-dua ni, equation ni adalah sama. They are equivalent. This is just telling us more information that P bergantung kepada T. So now, I will substitute this P. So the value is going to equal 6.1. And then I'm going to have P naught. So exponential of K. So I can ganti nilai T. So T for this case, dia adalah sama dengan kosong. So kalau you tengok, I ganti dua nilai. So the first value that I replace is going to be the P. So the second value that I replace is going to be the t. Sebab I ada dua nilai ni, p dan juga t. Right, so when I use these two values in my calculation, okay, so I will get here exponential of 0. Let me simplify this. I will get 6.1 is equal p naught exponential of 0. What is exponential of 0? Exponential of 0 is going to equal 1. That's right, it's going to equal 1. So therefore, I get the value that P naught nilai dia adalah sama dengan 6.1. So tu adalah nilai P naught. So I pakai information yang pertama. So next, what I'm going to do is, I akan update balik equation atas ni. I akan ganti that P naught nilai dia adalah sama dengan 6.1. So I update the equation. So this is the equation. So our equation adalah P sama dengan 6.1 exponential of KT. So that is going to be our equation. So now we only have one more constant for us to find, so which is going to be the K. So macam mana I nak cari nilai K? I have another one information which is going to be this. Yang bila T sama dengan 12, P adalah sama dengan 7.5. So you kena pakai dua-dua information. So 7.5 is going to equal 6.1 exponential K multiplied by 12. Sama juga case dia macam tadi. So dekat sini apa yang buat adalah I pakai this information, I ganti. So P adalah sama dengan 7.5. So T nilai dia adalah sama dengan 12. Ni you kena simplify lah. So you have to simplify this. So I will get exponential of 12K adalah sama dengan 7.5 per 6.1. How do I get rid of exponential? Macam mana I nak hilangkan exponential ni? What should I do?
Log.
Exactly. So you are going to ln both sides of the equation. So I can ln this side, log of exponential of 12K is equal log of 7.5 over 6.1. So automatically, sebab dia inverse, dia akan cancel each other. So I akan dapat K adalah sama dengan 1 per 12. So I bring this to the other side. So dia jadi 1 per 12. Log of 7.5 over 6.1. Can somebody tell me what is going to be the value of this? I don't have my calculator with me. Tolong type dalam chat tu.
0.0172.
So 0.0172, is that right? Okay, that's right. Thank you, Siva. 0.0172. Okay, that is going to be the value of K. So now that I dah tahu nilai K as well, so I akan update balik my equation. So remember our equation previously that we started with. So this one, so sekarang kita dah tahu apa dia nilai P0 dengan K. So I ganti, what is going to be the value of K? So our equation P of T is actually going to equal 6.1. So exponential of 0.0172. So multiplied by T. Ni adalah kita punya equation. So kalau you nak buat calculation nanti, so you akan pakai this particular equation. So let me highlight this equation right there. Okay, so that is going to be for A. So here, kata determine the growth constant K. So I dah bagi equation siap-siap dah, cari nilai K and I even updated the equation. And then for B, dia kata estimate the population in year 2018. Okay, what does it mean by estimate the population of Mexico in year 2018? Maknanya dia suruh you cari apa dia nilai P bila T tahun 2018. So maknanya T sama dengan berapa ni? What is the value of T?
T18.
18, that's right. So T is going to equal 18. Maknanya apa yang you kena buat adalah, you pun carilah. So P18 adalah sama dengan 6.1 exponential of 0.0172 multiplied by 18. So dapat berapa sekarang? Siva seorang je ke ada calculator sekarang?
$8.314.
8.314? Okay.
Yep.
Tapi you kena ingat, ni bilangan orang. Dia bukan 8.314 orang tau. Ni adalah 8.314
So approximately 8.
million people. Sebabnya tadi dia bagi ni sebenarnya 6.1, ni sebenarnya 7.5 ni dia adalah dalam unit million. Sebab tu bila dah kira, you kena tulis dia adalah 8.314 million. Okay, that is going to be for B. Okay, C pula dia terbalik. So dia kata when maknanya dia tanya bila. Apa dia nilai T bila population tu sama dengan berapa? What is the P value?
15 million.
Betul. So you tak payahlah ambil million, you ambil 15 saja. So dia tanya what is going to be the value of T bila P adalah sama dengan 15. Maknanya you pakai equation ni juga. Tapi sekarang P ni adalah 15 is going to equal 6.1 exponential of 0.0172T. Sekarang you kena cari T sama dengan berapa. Ni I leave it to you. You cari sendirilah berapa dapat nilai T, but this will be the idea. And macam mana you nak suruh T ni turun, you kena log both sides of the equation lah supaya get rid of the exponential. So that is what you're supposed to do. I'll leave it that to you to find what is going to be the value of T for C. But that will be the idea. Untuk second equation ni dia complicated sikit sebab you kena extract information daripada cerita and then only you boleh cari nilai P0 dengan nilai K. It is harder than the previous one. Right, so any question? Before we stop? Okay, I will spend some time to compile exercise for chapter 3. And I will also send you the previous test questions so untuk you punya revision, because our test is going to be next week. So hopefully you can spend time on your revision. Sebab test is a very big percentage, 30%. So sometimes the test can actually decide whether or not you're going to pass the course. And if you aim for an A, of course you have to do very, very well for the test. Right, so I don't have anything anymore. Scroll down. Okay, don't worry. Sekejap lagi I snapshot, I hantar dekat group. I don't have anything unless you have anything to ask. Then there's nothing more from me. So I think I'm going.
Madam.
Yeah.
Miss, sorry.
Mm.
Just now for the question, right?
Mhm.
The C.
The C.
I got the answer 52.31.
52.
So I just can approach 0.31.
Mm-hmm.
So I just can approximate it to
52.
2052, right?
Yeah, that's right. So it's going to be about. So I just put approximately. So T approximately. So it's going to be 2052. So the rest of you should try to calculate as well. Betul tak you dapat 2.2052? Okay, anything else?
Good.
Okay, so if you don't have anything anymore, so don't worry about this. Sekejap lagi I snapshot, I hantar dalam group. So let's end here for now. And next week, I rasa kita akan buat revision for tests for our next online class. Right, let's end here for today now. So see you guys then. Bye.
Okay, thank you.
Thank you, Miss.
No problem.
Thank you, Miss.
All right.
Thank you, Miss.
No problem.
Thank you, Miss.
No problem.
Thank you, Miss.
No problem.
Thank you, Miss.
Okay. I should stop the recording.